This is for lesson 8.4 of the Advanced Algebra textbook. In lesson 8.3, you covered how the square root of 2 can be rewritten as 2 to the half power, or for example, the cube root of 8 can be rewritten as 8 to the third power. In this lesson, we'll be covering multiple things, the first of which is the difference between an arithmetic and a geometric mean. So I made some sample problems. For finding the arithmetic mean, that's when you add all of these together and then divide it, probably the thing that you're used to. For example, 1, 2, 3, 4, and 5. You add 1, 2, 3, 4, and 5 together, which gives you 15. And since there are 5 values, you divide it by 5 and you get 3. The geometric mean is very different from the arithmetic mean. So instead of adding them together, you'd multiply all the values together. So 1 times 2 times 3 times 4 times 5, which is 120. And since there are 5 values, instead of dividing it by 5, you find the fifth root. So, and you answer that, which would be about 2 605 thousandths. An easy way to remember the difference between arithmetic mean and geometric mean is to look at how arithmetic starts with an A, and so does adding, and average, which is another word for arithmetic mean. And then to find the difference between them, geometric sounds like geometry, which has to do with shapes, and a square is a shape, and squaring stuff has to do with finding the root. The second part of this lesson is learning which nth root this equation represents. The nth root of x equals x to the 1 nth power. It only represents the positive real root when n is even and x is positive. So, for example, take the fourth root of 16. This actually has 4 solutions, but the only one that this represents is 2, because 2 to the fourth power equals 16, so this can be 2. There's also another solution to it, but the equation has to be written differently. Negative 2 to the fourth power also equals 16. However, to get that, you have to write the equation as the negative fourth root of 16, or negative 16 to the fourth power, because it's not represented by this equation. There are also 2 other complex solutions. There is 2i and negative 2i, because 2i cubed is, 16 times I cubed, and I is the square root of negative 1. So negative 1 times negative 1 is negative 1, and then negative 1 times the square root of negative 1 times the square root of negative 1 is positive 1. So it's positive 1 times 16, which is 16. This also equals that, but it has to be written in a different way to get that, because I is a complex number. It's not a real number. That would be the same case with negative 2i. You would have to write both of these as the plus or minus fourth root of 16. The last part of this lesson is finding the roots of roots. So say you're given the problem, the root of 200. So the way that you could solve that is rewriting it as 200 to the half power, in parentheses, to the half power, which gives you 200 to the 1/4 power, which again can be rewritten as the fourth root of 200. And this kind of goes for any exponent. So the third root of the fourth root of 200 can be rewritten as 200 to the fourth root, in parentheses, and then to the third root, which can be simplified as 200 to the 1/12th root, or to the 1/12th power, or 200 to the 12th root.